I'm Cole.
And I'm Blake.
And this is our calculus project.
Wow, what a powerful shot! That relates to this calculus problem in which we are asked to use the power rule. So, f of x equals 4x to the negative 2 plus 1/4 x squared. And we are being asked to plug 2 into the first derivative of f of x. So, we'll have to use the power rule in which we multiply the coefficient times the exponent and subtract 1. So for the first derivative, that would come out to be negative 8x to the negative 3 plus 1/2 x. And now we are asked to plug 2 into the first derivative. So 2 times negative 3 is 1/8, and 2 times 1/2 is 1. So negative 8 times 1/8 comes out to be negative 1, and negative 1 plus 1 equals 0. So that is D, 0. Go.
Thanks, Blake, for that explanation of the power rule. Now we will be going over the quotient rule. So first, let's look at our problem. We are instructed to find the derivative of x plus 1 over x squared plus 1. Now for this problem, we're going to use the quotient rule, which is defined here. So we take g and multiply it by the derivative of the top, or f, subtracted by f, the top of the equation, and multiplied with the derivative of the bottom of the equation, all over the bottom of the equation squared. So let's look at that in context. So we are instructed to take the bottom, x squared plus 1, right here, and multiply it by the derivative of the top. Now when you take the derivative of x plus 1, the constant's going to go away, and the x goes away, and we take the coefficient of the x, which is 1. Then we subtract it by the top, which is x plus 1, and the derivative of the bottom, which is this. Now we learned from Blake in the power rule that this 2 is just going to come to the front to make it 2x, and this constant, as I said before, will go away. And all of that will be over x squared plus 1 squared. Now, this part of the equation, the bottom, isn't going to go away. It's not going to cancel out for the rest. So know that this is just going to go away for a while, but it's always there on the bottom. So now we're going to simplify the top by multiplying 1 through here, which will change nothing. And then we're going to FOIL 2x times x plus 1. 2x times x is going to be 2x squared, and 2x times 1 is going to be 2x. And then we simplify further by distributing the negative through to make it negative 2x squared minus 2x. And then finally, we can simplify right here because we have 2x squares. So 2x squared plus x squared is just going to be negative x squared, then negative 2 plus 1, and then the bottom that we talked about up here, and that just went away. And of course, that is going to be answer C right here. Man, I wonder what the maximum of that ping pong ball is. Similar to this math question about the relative maximum of this equation. So let's read the problem. It says, the function has a first derivative given by f prime of x equals x multiplied by the quantity x minus 3 squared times x plus 1. And it reads, at what values of x have a relative maximum? So to find the relative maximum, we have to use the first derivative of the given equation. However, we already have that right here, right? So all we have to do is find the zeros of this equation. So 0 makes x 0. If you plug in a negative 3 here, 3 minus 3 is 0, and negative 1 plus 1 is 0. So we found our zeros, and then we arrange these numerically. So now we have to find the direction of these arrows, and we do that by testing points in between these and at the lower and upper extremities. So we'll take negative 2, for example. I plug in negative 2 to x, I get a negative 2. Negative 2 minus 3 is negative 5, but negative 5 squared will be positive. And then negative 2 plus 1 is negative. So we get negative, positive, negative. If you multiply those together, you're going to get a positive slope. So then I test a point between negative 1 and 0. I'll test negative 0.5. Negative 0.5, this will be negative 3.5, but squared, so it'll be positive. And then if I put in a negative 0.5, it'll still be positive. So I have positive, positive, negative. So my arrow will be negative. Then between 0 and 3, I'll test 2. So we have 2, which will make this positive. 2 minus 3 is -1. -1 squared will be positive. And then I plug in a 2 right here, positive, 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 which is arrows. And then, of course, past here, if we test a 4, we'll get 4, 1, and 5, which will make a positive slope. So the only time in which we have a maximum will be right here, when the points go from up to down. This would be a minimum, but we're not looking for a minimum. We're only looking for the relative maximum. So it has to be at x equals -1, which is answer A. Wait, Blake, where are you? Oh, there you are.
Thanks, Cole, for showing us how to find the relative maximum and minimum for the first derivative. And now I'm going to show you the second derivative and how it finds the concavities and the points of inflection. So, for what values of x does the graph of y equals 3x to the 5th plus 10x to the 4th have a point of inflection? So first you will have to find the first derivative by using the power rule, and that comes out to be 15x to the 4th plus 40x to the 3rd. And then you'll take the second derivative, and that comes out to be 60x to the 3rd plus 120x squared. And then you will have to factor it, and that comes out to be 60x squared with the product of x plus 2. And now you will have to set it equal to 0, and that gives you -2 and 0. So for these points, you will have to find the positive and negative to see what the slope looks like. So if you plug in a -3, you get a negative and a positive, and that is down. So then you would plug in a number between 0 and -2, such as -1, and that will come out to be a positive and a positive, and a number between 0 and infinity, and that will be positive and positive. So that comes out to be -2 only, and the concavity doesn't change at 0, so that is x equals -2, B. Oh, dude, you
What?
gotta stop eating that.
What?
It could give you cavities.
Cavities, like concavities? Speaking of, let's take a look at this math problem. So, the problem reads, let f be f of x equals 2x to the 3rd minus 3x squared minus 12x plus 18. And it asks us on which interval is f both decreasing and concave up. So for decreasing, we know that we're going to have to find the first derivative, and for concavities, we know we're going to have to find the second derivative. So let's take a peek at the first derivative. We're going to do, here's our problem, we're going to do the power rule, and then we're going to take out a 6, so we get 6 equals x squared minus x minus 2, and we know that this can be factored into x plus 1 times x minus 2, and that'll give us zeros at -1 and 2. So just like our problems before, we're going to draw our little number line and test a point below here. So -2 over here makes a negative number, and a 6. So negative is positive. We're going upwards. Then we plug in a 0. This will be positive. This will be negative. So negative times positive is negative. And then a 3, positive, and we know it's going to be positive. So now we're going to take the second derivative. So up here, again, we do the power rule, and we get 12x minus 6. Again, we take a 6 out to get 2x minus 1, and we can see that x equals 1/2. Again, our number line, 1/2, and we're going to test a point down here, such as 0. If we plug in a 0, we get a negative, and if we plug in something like a 1, 0, 6 times 0 is going to be positive. So we get positive. So now we have to look at where it's both decreasing and concave up. So we know it's concave up from 1/2 to infinity, and that it's decreasing only between -1 and 2. So we know that it has to be both decreasing and concave up between 1/2 and 2. That is the only point where they both intersect. And that's how you do that.
What? Is this a horizontal asymptote I see? Which brings me to problem 24, where we are asked to find the horizontal asymptote of the function f of x equals 3x plus 8 times the product of 5 minus 4x divided by 2x plus 1 squared. And in this case, we are going to FOIL first. So 3x times 5 is 15x times minus 4x, which is minus 12x squared. And then 8 times 5 is 40, and 8 times negative 4x is minus 32x. And you are going to do the same for the bottom. And once you come out to this, you are going to have a simplified version. So minus 12x squared minus 17x plus 40 over the bottom. And because the exponents are the same, you're going to divide out the coefficients. And if, say, the numerator of the exponent is greater than the numerator of the denominator's exponent, then y would equal 0. And if the denominator is greater, then there is no asymptote. So, as in this case, the exponents are the same, we divide out the coefficients. So, minus 12 divided by 4 is minus 3. And that is B, minus 3.